Swayam Prabha. Digital India. Educated India.
Welcome back. Now, we have seen already how mappings work, and we also have seen that a function must be either a one-to-one mapping or a many-to-one mapping. So thus succession is a function because it maps one thing, that is 0, to one, just one thing, 1 to 2, 3 to 4, and stuff like that. And also squaring is a function, but squaring is a different mapping. How? Let us call squaring function q, and let us just we can consider all whole numbers, not just natural numbers. Just let's do it. So for successive function, then if we want to consider this, it will be -1, 0. So you just include all of the steps there if you want. So we are just trying to make them similar, make them look very similar. Now squaring that way would be slightly different, because you get for example -1, 0, +1, 2, 3, and 0 gives 0, 1 gives 1. Now you can see that -1 is mapped onto 1, and also +1 is mapped onto 1. Now look here, and 2 is mapped to 4, and also -2 is mapped onto 4. Now see, this is actually many-to-one mapping. This is a function, and there is no problem with this kind of a mapping. So a mapping can be this. This is fine. A mapping can be this. This is also fine. What is not fine is a mapping like this. This is not fine. The moment you get this, so for example, square rooting is like this. Why? Because if square rooting is r, you can see that it takes 4, and on the one hand, so it takes whatever, it takes many different things. It takes 4, and it on the one hand gives you -2, on the other hand +2. That is the reason square rooting is a relation but is not a function. So we remember this form, that this form is prohibited as far as mapping is concerned, and other forms are fine. So fine forms are this is a fine form, and also this is a fine form. So the fork like this is not fine. So we can, after having done this, we may consider some very small rudimentary problems. For that we need to maybe erase a bit of it, and we can use this space for that. For example, we can consider the first and the second for this. Now the first one says, so let us assume that we may consider 3 functions: succession, squaring, we call succession S, that is a short form of the succession function, and let there be squaring, we'll call it Q, and also addition will be designated as M. So the addition function A takes M and maps that pair to M plus N. So it takes 2, 3 and maps that pair, that is 2, 3 to 5. This is how they work. Now these are things which we can understand very easily. Let's see the first example first, A, which is addition 2 square 3. Now we can very easily rewrite this function as 2 plus 3 square. Now which means 2 plus 9, which is 11. So now can you see that this also is kind of a composite function? It's a hybrid function. It's a mix of addition and squaring, that is a and q. And this mixed function, if you call it aq, remember aq will be different from qa. We'll see that. This function, this mixed function, takes 2, 3 and maps that to 11. Now it will take 1, 3 and map that to 10, right? So this is how this function works. And also we'll see that not that these two are the same functions, that is aq and qa. We just change. It will become, so let this be a prime. Just with this it will become q2. Then first of all you cannot even do it because a takes 2 arguments and q takes just 1 argument. That is the reason. First of all, this is not a very good construction. Secondly, even if you could do it, suppose both, for example, take we can take this. So that is how it is not possible for us to take qa, which is not a good construction. But then we can consider another example. We can consider m, which is multiplication, and a, and see how ma and am are not the same thing. How can we see that? Now for example, we take m to a to 3, anything it can be, which gives you basically 2 multiplied by 2 plus 3, which is actually 2 multiplied by 5, and that gives you 10. But a, which is once again a two argument function, will not do the same thing. This precisely means that 2 plus 2 multiplied by 3, which makes it 2 plus 6, which is 8. So you can combine functions provided they are combinable. You can very easily combine any function, but not that you can reverse, because the reverse need not be a function, as we have seen in the case of aq. qa is no function, but both ma and am are functions. Now we need to see another function. We can do many more exercises, but anyways we'll do another one. B, which is succession of addition of 2 square 1. This can be written as succession of 2 plus 1 square, which means S, succession of 2 plus 1, that makes it successor, that will lead us to the successor of 3, which means 4. So the value of this will be 4, and the value of this will be 11, as we have seen. Yes, it is 11. So this is how we do some calculation. This is, all these things are to understand the thing called function and how functions operate and what we can do by using functions. Now why have we studied all these things? Because we want to understand a few philosophical and linguistic theories which are absolutely essential to the field of formal semantics. Many of these theories are actually pioneered by Frege. I already mentioned Frege in the first session, and in the next segment, which is about Frege's philosophy of language, we are going to see how all these ideas will be required. So Frege talked about logic. Actually, for him, it was not natural language, but it was the language of reasoning. He talked about mainly the language of logic, but we know how to use that also for talking about natural languages. Anyways, we'll see in the next segment how all these ideas, functions, sets, and syntax to a very great extent, all these things will become very useful for understanding Frege's philosophy of language. So we start the next segment. In our next segment, we shall be talking about Frege's philosophy of language. This is another foundational element for formal semantics, another theoretical foundational element. Frege was a professor of mathematics at Jena University, Germany. He actually revolutionized, in the true sense, the field of formal semantics. Not formal semantics, sorry, those days there was no formal semantics, but he revolutionized the field of logic and mathematics by discovering new things, by inventing new tools, and by coming up with new theories. He was the person who for the first time formally defined number. So and his definition of number is now standard. He worked on in different areas of mathematics and logic. Today's logic, formal logic, is actually his brainchild. So his works are foundational to both logic and semantics. Now we shall see a few of his ideas that are relevant for our project. First of all, we shall see how he understood a declarative sentence, or to be more precise, not a declarative sentence, but a proposition. We know that a proposition has a subject predicate form. So Aristotle historically divided all propositions into 4 groups, and we can just see how he did that. So this is the famous Aristotelian square of opposition, and for him things were like all S is P, no S is P, some S is P, and some S is not P. We can see the square of opposition has already been formed, and Aristotle would talk about elements, the nodes of this square. It is not exactly a square, but it should be. Now, according to him, this proposition is universal affirmative. It is universal because it is about all. This is universal negative because here it is a negative sentence, no, and it is also about all S, that is, for every S it is true that whatever is given, and this is called particular affirmative, and this is particular negative. So there are propositions of 4 types according to Aristotle, and there are 2 parameters for understanding those. One, quality, the other one, quantity. So the quantity, let us consider quantity first. Quantity is like all, some, no, and stuff like that. And quality is yes or no. So is it a yes sentence, that is affirmative, or a no sentence, that is negative? Now we can see that the first one is universal, because it is universal because it considers all the S, every member of S. So this is universal and affirmative, and this is universal and negative. On the other hand, this is not universal, this is particular, but this is affirmative, and then finally This is particular but negative. So according to him, we could have prepositions of just these 4 types. Now, one example, if we instantiate these schematic prepositions, then we get something like, say for example, all humans are mortal, no human is mortal, some human is mortal, and finally some human is not mortal. After having said this, Aristotle would now talk about the relations between these prepositions and their qualities and quantities. We need not talk about that in details, but for us it is very, very important to understand how the prepositions are formed. This is the subject of the preposition, subject, that's why S, and this is the predicate of the preposition, P. Now, we can also consider a preposition, a singular preposition, like for example, Socrates is mortal. By the Aristotelian standard, or if you look at it from his perspective, this should be a universal preposition because it talks about all of Socrates in some sense. And also you could have something like X is mortal. X is a variable and it is not really quantified. Now, Frege did not like this kind of splitting. So we know that these are copulars. R or S is a copula, and subject and predicate. So basically a preposition is a relationship between a subject, a predicate, and a copula. Copula, if we write, and copula. Now, Aristotle did this thing long ago, 2,300 years ago, or maybe more, and logicians till 1880-90, until Frege published his works, did mostly this in the name of logic. So no new thing came, almost nothing came in the field, except some works by Boole and stuff, but that was slightly different. Also, you can notice another thing. This logic, Aristotelian logic, does not really talk about and, or, if, then, and stuff. So this is syllogistic logic. It does not know how to combine two different prepositions through the logical connectives such as and, or, if, then. Now, Frege wanted to combine the two ideas. That is, he wanted the subject predicate structure. At the same time, he wanted the logical connectives like and, or, if, then, or neg. He did that and came up with a very complex structure in his famous text Begriffs Schrift, and we will talk about some of the theories that are discussed in the text. First of all, let's see how Frege started, how Frege analyzed a preposition. Then we'll see what objections he had against the Aristotelian analysis. Frege says, statements in general can be imagined to be split up into two parts. Once again, statements for Frege basically are prepositions. This is a translation. So in German he would have written something else. Statements in general can be imagined to be split up into two parts. One complete in itself and the other in need of supplementation or unsaturated. Thus, for example, we split up the sentence Caesar conquered Gaul into Caesar and conquered Gaul. The second part, which is this, is unsaturated. It contains an empty space and empty place. Only when this place is filled up with the proper name or with an expression that replaces a proper name does a complete sense appear. That means he wants to say as if. This is the second part, the unsaturated part. This becomes complete. This is incomplete, we can see. This becomes complete only when you put something here. So there is a placeholder. Now, in the sentence or preposition Caesar conquered Gaul, what happens is Caesar comes and sits here. That's how it gets its completion. It could be something else. It could be Nero conquered Gaul or Attila conquered Gaul, anything. But the point is you need something. And we can also see that this expression is complete in itself. The moment I say Caesar, yes, it is somebody, I understand, Caesar. But then conquered Gaul doesn't have that sense of completion. So we read what he says. The second part is unsaturated. It contains an empty place. Only when this place is filled up with the proper name, which is Caesar in our case, or with an expression that replaces a proper name, does a complete sense appear. Here too, I give the name function to what is unsaturated, to what this unsaturated part stands for. In this case, the argument is Caesar. So this is from translations from the philosophical writings of Gottlob Frege by Peter Geach and Max Planck, 1966. We can see what he wanted to say. So, but the point is, he adds, he says, here too I give the name function to what this unsaturated part stands for. So this is a very important phrase, stands for. The unsaturated part means something, and it's very important for us to see what it means. So conquered Gaul has got, so meaning is not a very simple thing. We'll see that meaning is not a very simple thing. It comes in layers. It is a very complex idea. But the point is, this standing for is basically like referring to something. So conquered or conquered Gaul, both are unsaturated. They do refer to something, something that is there in the world. So what is that? According to Frege, that is a function. We have already understood function in the previous segment. Now we can apply our understanding here. Now for Frege, both Caesar and Gaul are proper names, and conquered a concept word. That is the unsaturated part. Now let us consider and compare these two sentences, which we take directly from the Aristotelian framework. All men are mortal, Frege is mortal. We have seen that for Aristotle, both all men and Frege are subjects, and mortal is the predicate. Now we need some kind of expression to differentiate between a word and its reference. So here an expression will be like this. It will be without any quotation mark or bracket, but the moment you have a bracket like this, it would actually So the expression, the word will be like this, or any phrase, but this is not the word anymore. Thus, Frigga, the word is Frigga, but this is not the word. This is the real person. Let us pretend that this is the real person, as if Frigga himself has been copy pasted here, and that's how you can you can differentiate this. So Frigga the word, and this thing Frigga, we may sometimes call it bracket Frigga for our convenience. For Frigga, the reference of a proper name such as Frigga is an object, and that of a concept word such as man or mortal is a concept. So there are two things. We can see what he was up to. It is not difficult to understand that. So precisely we can say that you can understand it this way. Here is a subject who speaks and understands whatever, and here is your world, right? Here is your world out there. The subject says something. So when the subject says Frigga, this is a word, but there is somebody in the world, and it's not that there must be somebody, but it is very likely that there is somebody in the world called Frigga. This person will be Frigga, and then the subject says Frigga is mortal. Here you will have a set of mortal beings, not just humans but all animals and many other things. So all these things are mortal, even the tree and all that stuff. So this set for Frigga would be the meaning, actually the reference of the word mortal. So this is the Friggan analysis. So we can see that words are here. Words are said and understood by somebody, but their references are out there in the world. So Frigga is out there. Frigga is not part of the calling cloud. We can see this calling cloud, but Frigga, actually the bracket Frigga, that is this, is part of the real world. So this kind of a relationship is there between words and their references. Now, as I said, this is an object and this is a concept or a function. Frigga is an object. Frigga means bracket Frigga is an object, whereas bracket mortal is a function which may be understood roughly as the set, and Frigga is a member of this set. This is how he would understand this thing. Now, the reference of man may be understood as the set of men. Frigga understood it slightly differently. For him, bracket man, which is this, is a concept. Now, we must talk about the relationship between sets and functions. We can understand that very easily. Suppose there are just 5 things in the whole world, and let us call those 5 things A, B, C, D, E. There is nothing else but 5 things, A, B, C, D, and E. Now, suppose A, B, and C are men, and D and E are women. Now, what will be then? Now, we shall see the relationship between sets and functions. Sometimes people speak of set and functions interchangeably in the field of formal semantics. They can do that because this kind of a relationship actually is held between sets and functions, or more precisely between the set talk and the function talk. So the man, we said that A, B, C are men roughly, and D and E are women. So the set man then would be A, comma B, comma C. Now you notice that we have started using what we learned in the last segment for talking about our ideas in this segment, and then you have this woman here. Suppose the names of A, B, C, D, E, names, not the real objects. Suppose the names are capital A, B, C, D, E. So A, B, C, D, and E. Now my sentence, once again we need kind of a subject, a speaker who says things. So suppose the speaker says A is mortal. A is mortal. What would the speaker mean by that? But by saying mortal, the speaker, or sorry, we didn't talk about mortal. We have just two sets, man and woman. So A is a man. Suppose this is what the speaker says. So at the linguistic level, this is fine. But what happens at the real world level? We can see very easily that the set A, B, C is the meaning of the reference of the word man. But we can convert this set easily into, so they're equivalent easily into a function that will have all individuals, that is A, B, C, D, E. But then the mapping will be different. All the members of the set, of the man set, which is if you look at the meaning of man or the reference of man as a set, then all the members will be mapped onto 1, and the non-members will be mapped onto 0. So this is how this set and this function, this set and this function, can be understood as equivalent in a sense. We can have both talks. So when somebody says, when this person says that A is a man, so in the set talk, so we can differentiate between the set talk and the function talk. Here in the set talk, this person actually wants to mean that A belongs to the set. So what is the sentence we are considering? That is, A is a man. The meaning of the sentence. So this person, the speaker, means to say, now remember, this person couldn't have said A is a small a is a man, because small a is not part of his language, the speaker's language. Only the capital letters are parts of his language, because this is an object and this is a word. So we all the time differentiate between the two. So basically in the set talk, this means that A belongs to the set A, B, C. In the function talk, it has some other meaning. It will mean that consider this function A, B, C, D, E. You give it an argument which is actually A, and whatever something comes up. So in this case you get the truth value 1. But what if you change A to say E? What will happen then? Now our sentence is E is a man. We have seen that the name E refers to the object E, and that is not a man, that's a woman. So in the set talk, it actually means E belongs to the set, or rather E is a member of the set A, B, C, and here this mapping is done. Now it is evident, we are not getting into that, but we can see that this is not true. Similarly, this is not true. So membership, so in the set talk, membership, whenever we find membership in the function talk, we find mapping. We find this one mapping, if you call it, that is, if something is a member of a set, then that is mapped onto 1 by its corresponding function. So the set's corresponding function here, so the set and function are equivalent in that sense, and here it is membership, here it is the functional application, right? So this is one very important thing. Such a function is called a characteristic function. So it maps all the members to 1 and non-members to 0. So now we shall see what Frege wants to say. Mathematically speaking, a concept is a function. Thus man, that is brackets man, is a function that maps Frege, Russell and all other men to the true. The true is a technical term. It means the truth value 1, and all non-men to the false with the capital F, or the truth value 0. For Frege, Frege is mortal means the object called Frege falls under the concept mortal. Now only objects can fall under a concept, another concept cannot. Can you now see that we are slowly trying to see how Frege did not like, why Frege did not like the Aristotelian analysis. As we are trying to say, for Frege, the reference of the word Frege is an object that falls here, that is part of the world, and Frege, the word, will be here, and the word mortal will be part of this, whereas the set mortal or the function mortal will be a concept or a function. So this function also can be understood equivalently as a set, but for Frege mostly it's a function. Now from a contemporary, so what is this falls under? Falls under basically is kind of a membership. So in the set talk it is membership, in the function talk it is this mapping to 1. So if an object is mapped to 1 by the function f, then we can say very roughly, I am not saying this is very technically correct, but this is this is for understanding the idea. So if an object is mapped to 1 by a function, we would say that the object falls under that function, and if an object belongs to the set S, we would say that the object falls under the set S. So we can see that we can easily understand the reference of a concept word either as a function or as a set. Not that these are very different things, these are all the time mutually translatable. So falling under is kind of membership or mapping to 1. So Frege's falling under, that's what I have written here. Frege's falling under is like the modern set membership. But the point is, mortal as a concept is a set that consists of individuals, not of sets. What did it mean? It means that, let us consider once again the reference of the word mortal. What does it consist of? Things like A, these are objects, B, C, D, E, all 5. If you remember the old world, we talked about that there were 5 things, 3 of them were men and 2 women, and we consider that but all of them are mortal. So what would be then the reference of the word mortal? It would be this set. Now you can see that its members, each of its members is an object, not a set. What is a set of set? We could have a set of set like this. So for example, you have x, y, and then there is another member where you can have, so say x1, y1, and then you could have x2, y2. Now we can see that here, suppose this set is S. We can very easily see that the members of the set S are not individuals, but their sets themselves, right? Their sets themselves. But that is not true about this set, because here each member is an individual. Now, if we follow the Aristotelian analysis, we must say, what is it? We take our original sentence, that is, all men are mortal. In the Aristotelian analysis, all men would be the subject and mortal the predicate. The predicates. Now, the problem is, similarly, you could have something like Socrates is mortal. Now, can you see there is kind of an imbalance, kind of a discrepancy, because we understand the second sentence in a different way. How? Now, Socrates, we can easily see that the reference of the word Socrates is whatever this man Socrates. So a real man Socrates. So let us pretend that this is a real man. This is the person called Socrates, and mortal is a set. So the reference of the set mortal would be a set of individuals, A, B, and also you will have definitely Socrates among all other individuals here. And then you have C, D, and all that, so many others. So the point is, its member is an individual like Socrates or A or B or C or D. Socrates, what I meant by Socrates is the not the word Socrates, but the real person Socrates. Now, here the falling under is very clear. So yes, I meant to say that Socrates falls under mortal. I mean bracket Socrates falls under bracket mortal. That is fine. But the same does not apply here. All men is no individual. All men is once again a set. So the problem is, man is a set itself. It will have A, B, C, and Socrates. And others. So yeah, many others. So now this cannot fall under this, because both are sets, and the members of this set are individuals, not sets, and this itself is a set. So by no means man could fall under mortal, because man is a set and the members of mortal are all individuals, but Socrates could fall under mortal. So can we see, we can easily see, I hope, that there is a difference, big difference between the ways we analyze these two sentences. So that is the reason Frege was not happy with the Aristotelian analysis. Now, how does Frege analyze all these things? So we have seen that, we have already mentioned that Frege did not like the Aristotelian analysis. It is precisely because of this. Aristotle would have to say two different things for one kind of construction, both the subject predicate construction, but then the Phrygian falling under is not satisfied by both. So, in the singular sentence like Socrates is mortal, it was fine, but as far as the non-singular sentence, universal affirmative sentence was concerned, that is all men are mortal, it did not really work, because the set of man, I am just reviewing what we said. So, the set of man could not be a member of the set of mortal, because the members of the second set, the set of mortal, were individuals, whereas the set of man is a set itself. So, then how could Frege handle these issues? For Frege, a sentence like all men are mortal means something completely different, very different from what Aristotle would say. So, for Frege it means this: for all x, if x falls under the concept man, then x falls under the concept mortal. This is how Frege would understand it, which means something like this: if x belongs to the set of the set which is denoted by, which is referred to by the word man, then we put a bracket, x belongs to the set designated by mortal. Here you can see that the analysis will be completely different. On the other hand, a singular proper name, Socrates is mortal, will have a completely different analysis. What is it? It is simply Socrates, if Socrates is the person. Let us pretend that Socrates is the person Socrates. Socrates belongs to the set mortal. Now, we can see two things here. One, we can see the difference, the difference between the analysis of the two sentences. That is, here it is a very different structure, and there is an if-then setting between two different sentences, two different prepositions. Here it is just one preposition, and here it is just one preposition, but here it is like, you can see it's a composite sentence. So, although they look very similar, all men are mortal and Socrates is mortal, they are very different conceptually. This was a major achievement of Frege, this kind of an analysis, because you can see this is how also the logician deviates from the grammarian's analysis. For the grammarian, both are subject predicate sentences, but Frege, or the logician for that case, would not be happy with the simple subject predicate analysis because of these reasons, because of having economy and the uniformity of the whole understanding of the whole framework. Now, in this new framework, grammar is not important. Underlying every grammatical construction, there is a logical construction, and that is the concern for the logician. For the logician, the grammatical construction is immaterial, but it is indicative of the logical construction. In such a way, we can somehow extract out the logical structure underlying the grammatical structure, but the grammatical structure is not the logical structure, because you can see, although at the grammatical level they are the same, at the logical level they are completely different. So, this is their logical structure. So, for Frege, then some men are mortal, this is just to give an example, some men are mortal could be understood as something like x belongs to man and x belongs to mortal. So I am not quantifying this x. I am not saying, actually I should quantify, I should have said that this is actually some x. We are not doing that. So actually I should have added this. Yes, I am adding this practically. I should have added this also. So I am adding, but I am not talking about it right now, because when we do predicate calculus, anyway we have to take all these issues very, very seriously, and we have to elaborate on each of these issues. But this is a rough thing, rough understanding of how we can look at all these sentences. So the first issue was this kind of disparity in the Aristotelian analysis, and the second issue is here. Now let's consider two sentences. Frigga killed the tiger, and the tiger was killed by Frigga. Now can you see that in the first sentence, that is in C, Frigga is the subject and the tiger the predicate, and in the second, the tiger is the subject and Frigga is the predicate. Now another problem. So the entire subject predicate structure changes. So for C it is Frigga and tiger. For D it is tiger and Frigga, according to the grammarian's analysis, which was actually adopted by Aristotle. So this would be the structure, but definitely they share the same logical structure. That is, if you put it this way, killed Frigga tiger. If you want, this is the underlying logical structure. This is not correct. Once again, I must tell you that this is a very rough way of understanding it. The detailed analysis will be taken up later. But just to start with, this form, this logical form is the concern, the main concern for the logician. But this structural difference is not their concern. But for the grammarian, these have different structures. So they have to be analyzed differently. Their understanding would be different, because this is an active formation, this is a passive formation, they have different grammars and everything. So for Aristotle, who follows the grammarian's understanding, the whole subject predicate structure will differ, whereas we can see that the logical structure doesn't differ. So we should not consider these two things, these two issues rather, these two propositions separately, because they actually are the same proposition. So this is another reason Frege did not like the Aristotelian analysis. So I gave two reasons, but there were many other reasons for Frege. Now Frege concluded that the Aristotelian analysis of sentences was wrong. Most of these arguments are presented in his Begriffsschrift, the text we mentioned. It was published in 1879. Finally, then, what is the summary of it? Frege says that every sentence, declarative sentence, has elements of two types: proper names, which are saturated, like Socrates, like Frege, like Russell, like Caesar, and concept words like mortal, man, and conquered, and all that stuff. In the next segment, we shall talk about the reference of a declarative sentence. Not that we will take up the entire discussion, we can just introduce, and then we shall take up each and every point separately and elaborately in the next session. Just to mention, to start the idea. Mathematically speaking, a concept for Frege is a function, as we have seen. So we shall divide the entire discussion into three parts. One is the intuitive understanding. We can see that by following Frege, we have to say that this is our intention to show that the reference of a sentence is a truth value. This is what we are going to establish. So how can we examine, how can we sort of establish it? In the first part, we'll go for an intuitive understanding of it. In the second part, we'll go for a pictorial understanding of it. That is, there would be some graphics and all that stuff, some graphical, some pictorial things to show what actually happens. And the third segment will be textual. So I will come up with Frege's original argument. So mathematically speaking, as we have seen that a concept for Frege is a function. Thus we have seen model, bracket model is a function. And when you could also understand bracket model as a set having Frege, Russell and all other model beings as its member. If you want to understand it as a function, then this function will map all model things like Frege. Now let us pretend Frege is the person, not the word, or Russell and all of us. This is the function model, all of us, to everybody, Frege, Russell, and say Strawson, all the mortal beings to 1, and all the immortal beings like say God to 0. We are assuming that God is immortal, and so this would be, there would be dots in it, and the equivalent of that will be the set talk, where you have Frege, Russell, comma, Strawson, and many others, but he will not have God on the list here. So God will not appear inside the braces here. So both the talks are fine. This is what we have seen. This conquered is another function. Now this is very important. We are not talking about functions of this type. Conquered is another function that maps an ordered pair to 1. It maps any ordered pair x, y to 1 when x conquered y is true. So to say, the function conquered would look very different. It will map, just I will take some time for erasing it. It will map actually the ordered pairs, like we don't need this because the set talk is not central to our discussion right now. We just talk about the function talk. So this will be a different mapping. Now assuming that Caesar conquered Gaul, we can say that Caesar Gaul will be 1, and also assume that Alexander conquered Egypt. This will be 1, but Alexander did not conquer China, so this will be 0. So unlike the old model function, this function is different because model mapped an individual, an object, to truth values, but this one maps pairs of objects, ordered pairs, not just pairs. Why the order? The order is important because this says that Alexander did not conquer China. This says Alexander actually conquered Egypt. So that is the reason here the ordered pair is very important. So it is not only Alexander and China, also it is the order in which the relationship of conquering holds between Alexander and China. So it is actually, it goes this way: Alexander conquers China and not China conquers Alexander. Now suppose f(x) stands for the function takes the argument x, and when a function takes the argument x, you get the value, whatever value it returns. So this is the general format of any function. So we'll just try to understand, because we need to now use shortcuts. All the time we cannot describe a function like this. The next question is, what happens when a function takes an argument? We'll take it up in the next segment. Thank you.